Objective of this project is to detect the optical disc present in a retina image, then segment the cup area, and then find out the amount of area of the cup with respect to the NRR rim. Now we start with the database. Let's take any of the database image. We are taking Drishti database images. First we need to consider the retina image. Now disc is essentially the most prominent part of it. This is this image cannot be detected, so let's take 24, any of the image. Now disc area is the most prominent area within the location of the retina image. So what we do is we first perform the color channel extraction. Once we perform the color channel extraction, we can clearly see that the red channel has got the highest intensity, and that the veins which flows through the region which flows through the center of the disc is suppressed in the red region. Now we perform an adaptive thresholding on the red region. Once we perform the threshold, it tries to find out the maxima of the image and select all the area which is 75% within the range of the maxima. We get the disc area, but it is not homogeneous, so we perform morphological processing by first eroding part of it so that small noises are eliminated, and then dilating it. Once we dilate it, we get almost accurate disc area. Now we locate the disc boundary. Once we locate the disc boundary, there is a bounding box which is placed on the top of the disc. The next part is to segment this part. So once we perform the segmentation, this disc part, only this much part, is extracted, and we can clearly see the cup boundary within this disc area. Now once you segment the disc image, only within that image the cup is much more prominent. Now if you consider the green channel within the disc, this green channel will show you the cup area in a much prominent way. So if you go for cup extraction, we detect the most prominent area within this cup region. So this is our overall disc region, this is the cup region. Now the first thing that we need to do is we need to compare the accuracy. This was image number 24. So what you could do is just click on compare disc accuracy, go to your Drishti disk, there is a folder called truth, select the appropriate image, go inside soft map. So this is my disk soft map. The accuracy for this image is 94%, as you can see. So this compares the area, amount of area being detected and amount of total area. Now our next objective is to find out the NRR rim. So what is exactly the NRR rim? The area between the disc and the cup is known as NRR rim. So we need to click on NRR rim. This is the cup area inside, and the outside one is the disc area. So we divide the NRR rim into 4 regions. First region is known as the superior, inferior, temporal and nasal region. Now our objective is to find out the overall area with overall area in each of this region. So we click on NRR area. So in temporal region it is 42, in superior region it is 31, in nasal region it is 35, inferior region it is 27. Now this area is represented as number of pixels divided by 1000. Okay, just to make it little simple, and then we can follow an NRR rule to find out whether this image has got a error or not. We further compare our method with an existing system, which is a Hop transform based method. So you can very well click on the disk detection by using Hop transform method. you can see that it tries to locate the disk boundary, but this is not as accurate as morphological processing. You can also go for the cup detection within the disk area. It locates the cup area within the disk. So this is the cup area that hop transform method detects. This is the disk that the hop transform method detects. You can further go for the accuracy analysis, go for image database, Drishti disk, truth image, say 24 soft map, just select the disk. The accuracy is about 88.82%. So we can clearly say that using our technique we can detect the disk with a higher accuracy than the existing technique.